Welcome back, everyone. We're going to be solving LeetCode 993, cousins in a binary tree. So given the root of a binary tree with unique values and the values of two different nodes of the tree, x and y, we need to return true if the nodes corresponding to the values x and y in the tree are cousins, or false otherwise. And two nodes of a binary tree are considered cousins if they have the same depth but different parents. So in order to solve this, we are going to use, I think depth first search makes more sense here, so we're going to do that. And the constraints, they don't give us a non-null tree, so yeah, the number of nodes in the tree is in the range of 2 to 100, so we don't have to check for a null tree. So let's say our stack is going to be equal to what are we going to have on our stack? Because we need to keep track of the value, or the node that we're at, which is going to be root. We also need to keep track of the depth we are currently at, along with the parent of the node that we are currently at, right? Because we want nodes that are at the same depth but have a different parent, right? So 2 and 3 are at the same depth, but their parent node is still 1, so we would return false in this case. If we go look at example 2, right, we have nodes 4 and 5 are at the same level, but the parent of node 4 is 2 and the parent of node 5 is 3, so in this case we would return true. So what we're going to do is we'll have a resulting array, and we are going to pop off the nodes of our stack, and if we ever run into the node x and node y that we're looking for, we are going to append the root, depth, and the parent of that node inside of this resulting array. And then at the end of our loop, we're just going to check if the depth are the same in both of those nodes and the parents are different. So we're going to run this loop while the length of stack is not equal to 0. While the length of stack is not equal to 0, we will run this. We will grab our node, we will grab the depth, and we will also grab the parent node. That is going to be equal to we're using a stack here, stack.pop. Okay, now we need to check if the node exists. So we'll say if the node is not none, what do we want to do? We want to check if the node.val is equal to x or the node.val is equal to y. If it is in either case, that means we have found the node that we're looking for. So what can we do? We can just say res.append. We're going to append a tuple, right? We need all three of these things. We're going to say, okay, we're going to grab the node.val. We are going to grab the depth and the parent, right? Otherwise, if this conditional is not true, we're just going to say, all right, well, if node.left is not none, we are going to say the stack.append. We're going to append a tuple, right? We need the node, the depth, and the parent. So we will append node.left. We will append depth plus 1, and we will append the parent. The parent node in this case is going to be just node.val. So we'll say node.val, and we'll do the exact same thing for the right side. So if node.right is not none, we will say stack.append a tuple of node.right, depth plus 1, and node.value. Okay, let's print out our resulting array so everyone can see what we have so far. Local variable depth reference, okay, so we need to give them initial depths. And in a tree, the initial depth, right, if we just have a single root node, the depth is just 1. And then parent in this case is going to be root.val. Okay, so let's run this. We should get a resulting array printed out. Perfect. So we have our node value 5, and this is test case 2. So we've got node value 5, node value 4. what do we have here? X is 5, Y is 4. Okay, so we got the right node values. Now the depth is the second value we have. Depth is 3, depth is 3. Okay, perfect. Now the last value we're checking is the parent node's value. So the parent node of 4 should be 2, which it is in this case, and the parent node of 5 should be 3, which it is. Okay, so now all we have to do is just say we're just going to check the values of these two nodes, and this resulting array is only ever going to have two nodes in it. So we will just say return result of the first element at position. What are we going to check? We're going to check the depth first. So we'll say position 1. If that is equal to the second element in our list at position 1, and we have to check the first element at position 2, which is the parent node, we have to make sure that those are different. So we have to say first element at position 2 not equal to the second element at position 2. So if this is true, right, we're going to get the right answer. So let's run this. And we do pass all 3 test cases, so let's submit. Perfect, it runs. Now, time and space complexity. Space complexity is going to be bound to the length of our stack. And I believe since our resulting array is only ever going to contain 2 nodes in it with a tuple of length 3, it's always going to be only 2 nodes in here. So I'm going to say our space complexity is going to be O of n, where n is the length of our stack. Or I could just say stack.length here. And the time complexity is going to be O of n, where n is the number of nodes in our tree, because we are traversing every single node in our tree. All right, and that'll do it for LeetCode 993.